Okay, thank you very much. Welcome to one of the last tutorials of the week. Well, it's actually the last tutorial of the week, right? This is empowering SNOMED CT implementations to expression constraint language. So thank you very much. We'll be reviewing all the different aspects of the ECL language and applications. So let me switch to presenter view here. So basically, most of the people who are here already know what SNOMED is, right? And SNOMED is a semantic network that represents clinical meaning. And this is related to how we use ECL, because ECL is the tool, the instrument that will allow us to navigate that semantic network, right? To take advantage of all the content in that semantic network. Everything in SNOMED, the more than 350,000 concepts, are nodes in that network, yes, and those nodes are arranged in different domains, in different hierarchies, according to different classification characteristics of each concept. The collection of elements in SNOMED is also includes identifiers, of course, descriptions, and definitions. And all of that is available to the ECL now. ECL has features that we can search the nodes, we can search the relationships, and we can also filter by descriptions and by identifiers. So basically, when the doctor uses SNOMED, of course, they don't see any codes because they interact with SNOMED through natural language. They do search and select concepts, looking at the descriptions. But we know that behind that, each concept that they select, each thing that they see in a search panel has a code in the back, and that identifier is related to the description that the doctor is seeing. But also that these codes are related to other codes via relationships, and there are groups in different hierarchies, like I said before. But they are also related to, if, for example, a procedure is related to the method of the procedure, like excision, and the procedure may be related to the site of the procedure, the organ being affected. And this is what creates this graph, this ontology, this semantic network of SNOMED CT. And what we will see today is the mechanisms that we have at hand to be able to navigate this network, to be able to select parts of this network for a particular purpose. Yes, and the mechanism has been evolving a lot, and it's really very powerful. So we'll look through all the different aspects of that, and then we will see how we use this mechanism in different use cases today. So we hope this is useful for you, and we will start to help you see all the different news and details about how you can take the most advantage of the knowledge graph. Thank you. Kai, now we continue to the next slide.
Thanks, Alejandro. My name is Kai Kewley. I'm part of the implementation support team at SNOMED International. Yeah, let's carry on. So I'm going to introduce expression constraints. I'm going to start by introducing the concept model and how that can be represented as expressions, and then how expression constraints can constrain the set of expressions that you're matching. It's kind of an academic way of describing it, but we'll get into it. So here's an example of a concept definition. And as you know, concepts are related to each other through various types of relationships. This is the SNOMED concept diagram format. And it shows in these purple boxes the ISA relationships. So this malignant tumor of lung is a malignant neoplasm of the lower respiratory tract. It is also malignant neoplasm of thorax and a neoplasm of the lung. And then it has these attribute relationships down here as well. So it's common that a disorder will have a finding site, which is some body structure. And this one also has an associated morphology. So that's a change that's happened to the body structure, and it's a malignant neoplasm. So this is how the definition of a concept can be represented in a formal way using all its relations. They've got the ISA or subtype relations, and the attribute relations. And those, it's worth drawing this distinction because those work in very different ways in ECL, in the expression constraint language. So let's have a look a bit more about the concept model attributes. So the attributes represent characteristics about the meaning of a concept. There are more than 100 defining attributes used across all of SNOMED CT, although they're broken into different domains. Not all of them can be used on every type of concept. We've got some of the very common ones here, like the finding site and the associated morphology. So to govern all these 100 different types of attributes, we've got the concept model. So the concept model is a formal way of saying, no, this is a different slide. So the concept model specifies how concepts are defined and which attributes from relationships and values can be applied to each type of concept. So the concept model is represented in two different ways. It's kind of like the rules that govern the structure of SNOMED. They're represented in the editorial guide in like a human approachable format, and they're also represented in the machine readable concept model, which can help us build up queries. So all of these rules really are represented in this format. So every modeling rule consists of two parts. There's the attribute domain, which says, where this attribute can be used, which parts of the hierarchy does this attribute apply to. And we also have the attribute range. So for this attribute type, what values can it be given? What are the range of concepts that can be given to this type of attribute? So the domain, in this rule, the domain could be clinical finding. So any type of clinical finding can have this type of attribute. It's a finding site. And the finding site can have any concept which is an anatomical or required body structure. That's the range. So knowing these concept model rules helps us because we know, on the one hand, what the content in SNOMED CT is going to look like, and on the other hand, which attributes we can use when we write our queries to do expression constraints. There's another example here. We've got pneumonia with the finding site in the lung structure. So that's an example using this rule. So SNOMED CT expressions, we've seen already that this is the concept model representation of the concept modeling is the concept diagram, but we can represent the same thing in a different way. So this is an example of an expression. We've got all the same information in there. We've got the three parents here, and they're sort of plus together in this syntax. And then we've got this colon, and after that we have all the attributes listed, the finding site of lung structure, the associated morphology. So why is this important? The idea is with expression constraints is that you're writing a clause which constrains the set of expressions that you're matching, and these are the expressions. So there's another form of expressions. This is like the terse form. It's the same thing, but without the terms, because when an ECL engine runs, it usually doesn't look at the terms. They're not necessary, but it's just nice to make it more human readable. So we can see the expressions in the browser. I'll go and find some. In this example, we've got lung cancer. Alejandro has already opened the tab. Thank you. So if we go and look for, we go and look for lung cancer, we can see the concept, and in the expressions tab, well, first we could look at the diagram. And we've also got the expression tab here. And right at the bottom, we have the the expression for the inferred relationships of this concept. And the inferred form, after classification, that's what the ECL uses to match concepts on. So then we move on to, we can see the inferred definition. So every concept has, as well as having just a concept identifier, which you could use for selection, we've also got the inferred definition here. And there's 3 examples. We've got 2 disorders, which have finding site, and we've got a procedure, which has a procedure site. So the expression constraint language is a computable rule that is used to define a set of clinical meanings. Now, there may or may not be any results to the query, and the expression constraint or the query kind of exists independently to the substrate that you're running it on. So on one version of SNOMED CT, you may get 100 concepts, and on the next version of SNOMED, you may get more, you may get less, and the same expression constraint can be used. So for example, here we've got lung disorders with a morphology type of edema. So this is, we're saying we want, this is an operator. I'll go into these in the next slide, but we're saying that we want descendants in the hierarchy of disorder of lung, but we want to filter that to say, just give me those that have an associated morphology, some type of edema. So that's what a common expression constraint query will look like. So really it's a SNOMED query. It's like a SNOMED query language. Maybe that would be a better name for it. So we've got the focus concept here and the refinements. So if we ran this SNOMED query or this ECL, these would be the valid concepts or some of the valid concepts that would match. They're all disorders of lung. They all have an associated morphology of edema or some type of edema. You notice here that we're actually not asking for edema specifically. We're saying descendants and self of edema. So it could be this specific concept edema, or it could be any other subtype of edema. They'll all get matched if they're a lung disorder. So I've talked a little bit about the substrate. So first of all, we take a substrate, which will be some version of SNOMED CT. It could be the international edition or a national extension. And then we apply the expression constraint, and it's really like a filter to apply the rules to see which concepts can match. And then we get the expansion. So they're kind of the results of the query. So this is going to get complicated, but I'm going to call out some of the key parts of an expression constraint. So we've got the focus concepts. That's kind of where you start. It like anchors you in a part of the hierarchy to start with, to start your hierarchy navigation or your filtering. You start somewhere. And here we've actually picked 2 focus concepts. The one on the right-hand side is actually a reference set. The one on the left-hand side is a more common way to start. You're picking some place in the hierarchy. We've got the clinical finding, and we're saying we want the descendants of clinical finding, and this is a ref set operator, and any concept that's a member of the cardiology reference set. So we're starting with those before we apply any filtering. We've got a constraint operator here, which are usually used to, look down or up the hierarchy. And we've got a member of function, which is pulling all the concepts out of that reference set and saying, I want these in focus too, to start my expression. We've got the conjunction operator saying, I want them both. There's different types of conjunction operator. You might say, and. This means they've got to be in both. You might say, or, I want the whole set. You might want to say minus. I want the clinical findings, but take away the cardiology reference and members. So we're using conjunction there. And then we've got any refinements, and the refinements come after the colon here. So in this case, we're refining with 2 attributes. And we're also specifying that they have to be in a group using the curly braces either side. So they have to be within one role group, both of those attributes. Be using a disjunction operator here to say that if any one of those attributes are within a group, then it should match the constraint. We've got pairs of attribute names on the left and attribute values on the right, although it's not displaying. Attribute values are here, obviously. And even the attribute types themselves sometimes need operators, because the attributes actually, in some cases, form a small hierarchy. So associated with has got some subtype attributes. That's something to watch out for. So there's a big long list of symbols in the expression constraint language. I recommend starting with the hierarchy operators, descendant of self. It's a good place to start. But they're all detailed in the ECL guide. There'll be a link at the end. Yeah, please. Yes. Yeah, I don't know if anyone's for people online, the question is about the curly braces in this example. I'm going to go back so that we can see it a bit more easily. So what do they mean specifically? These curly braces they're saying that these attributes have to be in a role group. They're not, if either one of these attributes are in any role group, then they'll match, because we've got this or operator. If we'd use an and, then they would both have to be in the same role group. Yeah. No. This definition means they have to be grouped together. It's a bit confusing because we're using an or. either one could make it work. If we had an and the same syntax with the curly braces, it means they've both got to be in the same role group. We can't use 2 sets of curly braces. That doesn't work in this language. Yeah, good question. So we haven't got a roaming mic in this room. I'll just repeat the question. We do. The question is, if we remove the curly braces, would we get the same answer? It depends if if there are any concepts that have got an associated morphology which isn't in a role group, then that would only match if we took the braces away. So yeah, it does change. Yeah, you got it. Forces you to only look in role groups.
I don't know how to bring the mic there fast enough. Now it's on, right?
So what?
Yeah, sure.
So I think I have a light. So you're saying if it's a role group that the first one is in and will have other members, or the second one is a role group with other members, they don't both have to be in the same role group together.
Only because we're using the or operator. Right.
But
if we're using and, they would have to be in the same.
But will the query find concepts that only have associated morphology of infarct, or does it have to be in a role group with something else?
It would find both concepts that have an associated morphology of infarct or associated with myocardial infarction.
Well, what if it's not role group with anything and still find it?
If those attributes are in the concept but they're not in a role group, then you won't match.
Okay.
So the same. It's funny that We're going for so long on this one. If I put a curly brace here, yeah, to say just this one has to be in a role group, and I put another curly brace here to say just this associated morphology needs to be in a role group, it would work exactly the same in this case because we're using OR. But yeah, you should play with it in the browser. Since we focused on this one, I need to make a disclaimer. This example came from someone else, and the syntax is not valid. And the reason the syntax is not valid is because we have two focus concepts. And then we've started applying some refinements. And these need to be in a subquery, in a soft braces, you know, because this syntax is not valid. So you're welcome to try it in the browser and see what the error handling is like. But yeah, taking away one of the focus concepts would make more sense because this reference set isn't in the international edition anyway. All right, I'm going to move on. We've got some examples here of pre-coordinated concepts and what their definitions look like as expressions. And let's look at some examples. So if we consider, give me the descendants of disease, you know, which concepts will match. Of course, both the disorders will match, but the procedure won't because it's not a descendant of disease. We view the descendant operator here. What else can we do to narrow it down? If we were trying to find the cyst of the kidney, we could keep our descendants of disease and we could put on a semicolon and we could add another constraint. The disease has to have an associated morphology, which is a descendants of self of cyst. And then we'd narrow down to the cyst kidney, the cyst of kidney.
And you can see how usually you don't use the curly braces at all, unless you really want to make a distinction between something that is group or not group. That is not a common use case. Normally you don't use for queries the curly braces.
Can you think of an example where you'd need them?
No, for example, if you have a complex procedure that has an insertion of a device for the destruction of something, for example, and you insert in the vessel, in the artery to destruct a thrombus, and you don't insert in the thrombus and you don't destruct the vessel. I mean, you have this, when you have two role groups in the definition, and you would be very specific about that, you would say, give me all the descendants of procedures that have a method insertion with a side artery, curly braces, and that will have to match exactly like that. Otherwise, it could match something that it has a different meaning. But usually you don't need to do that because that's like a complex query. Yeah.
So if we look at our cyst of lung, okay. This is about the fact that we've said any type of cyst. So we want a disease with associated morphology of any type of cyst. And we would actually get the cyst of lung, which does have an associated morphology of cyst. And we will get cyst of stomach. But there's also a concept that exists, ganglion cyst of right ankle. And that would also be included because although it doesn't have an associated morphology of cyst, it has one of ganglion cyst. And ganglion cyst is a type of cyst. So it will still be included in our results, which is probably, you know, what we want. So I think you nearly always want to use descendants and self, whether you're using the focus concept or the attribute type or the attribute value. So we've got a few more examples here. Maybe there'll be more discussion. Here we're asking for finding of the left arm. That's what we're trying to find. So we've got all clinical findings with a refinement of finding site. And here we've got a subquery. So the subquery uses the soft braces. So we're defining a new set. This will get executed first by the runtime engine. So it's going to find all the types of upper limb structure that have got the laterality of left, and they'll be used to match the clinical findings. So it will be any finding site of the upper limb structure with the laterality of left. That's kind of useful. There's no limit on the number of nests you can use, but I guess it gets a bit difficult to understand if you use lots, but the language allows it. here, it's kind of negation. We say that we don't have negation in SNOMED, but we do have it in the ECL language. So we're able to say, give me the disorders of the lung, but take away the edemas of trunk. Here this is a different type. I said that you usually start with a focus concept. You can start with, well, I want to filter the whole ontology, and then I just want to do some refinements. So we're saying any concept across all of SNOMED that has a finding site that is not a heart structure. That's how you'd run it.
I think that in the public browser, that is really slow.
Yeah.
So usually it's better if you select some pattern, even the root concept, right?
Yeah, and we know from the concept model that the finding site can only be used in the clinical findings. So kind of lazy to put the star on you. Yeah. Maybe you'll start crashing your server, but you could.
So minus of that is the same.
No. In this case, we're defining two sets here. It's like set theory. We're not doing filtering. We're saying I've got the set of all disorders of lung, and I've got another set which is edema of trunk, which is obviously a type of disorder. And then we're doing the set theory. We're taking that set away from the other set. It's not really filtering on the attributes. It's not using the attributes at all. Actually, it's using the hierarchy. Saying we're taking one part of the hierarchy away from a higher part of the hierarchy. Whereas with this minus, this is actually saying I want to filter on an attribute. An attribute isn't the hierarchy, it's a different type of structure. It's like attributes go across in the hierarchy. Often the disorders or the procedures are linked crossways to the other hierarchy, the body structure. So this one is saying, give me any concept where the finding site, which is across linking attribute, isn't a heart structure. So I guess it's similar because you're kind of taking the set of all possible finding sites and you're taking away the heart structure. So it's kind of similar, but you're acting on those defining attributes that are attributes. But
the difference, the distinct, the not equal, is in the refinement level after the colon.
Right.
Yes, it's separating the relationship type with the value.
Yeah.
And the minus is merging sets, like I said. In this case, it's merging two focus concepts, but you could have two complex expressions with a minus in the middle, and it will do subtraction between those two.
Hmm.
Can you put those actually, or is there a requirement that minus more than both?
And then you need like parentheses to say this is an expression minus this other expression.
Not minus.
No, that will be incorrect because expression will be incomplete. You have no value for finding set.
Yeah, the syntax only allows the use of minus before the refinements, essentially.
Yeah.
Dr. Park, did you have a question? Can you take the mic?
Minus only can apply to same hierarchy, top level hierarchy, right?
No, actually, minus, if you're right, that's the right way to do it. Yeah. But if you do minus to a different hierarchy, it will have no impact. It's like saying all this minus all that is not here. So it will be still all this. You're right. But it's not an error. You will not get an error. You will just get the same as the.
I suppose you can say minus can only be applied with the focus concepts when you're doing your hierarchy constraints, can't they? Before you go into the colon part where you've got your refinements. Here we've got the first example of using cardinality. So cardinality is like how many of these things do I have? And it can be used when constraining, how many attributes of a type you have. It can also be used of how many groups of, with these attributes do I have? It could be very complicated with how many groups have I got with this number of attributes. It's all in the ECL guide, but it's not used very much. I guess it's used a bit in drugs.
Yeah, this is interesting because you get the drugs with more ingredients. Just as a curiosity, you can have them. But yeah, usually there are not many clear clinical use cases for this.
So this one's selecting products with 2 to 4 active ingredients. We've got one more slide of these. This one, we can see again, this is using the refset member operator. So I'm saying, give me all the concepts which are a member of the ICD-10 complex map. But this is the first example we've seen of a filter. We can filter on various other things. So filters are used for anything in SNOMED which is an attribute, but it could be somewhere else in the RF2. So in this case, we're filtering a map. We've got an M to say it's a map filter. And sorry, M isn't map, M is a member. So we're filtering a reference set member. And we can filter on any column on any reference set. So in this case, we're using the map target. So we're looking for an ICD, a concept in the ICD-10 map, which has got a map target to this ICD code. So that should give us kind of the SNOMED code that's equivalent. I wouldn't recommend using this because obviously ICD-10 is a complex map. It's a one-to-many complex map. So I'm not sure how useful this would be, but maybe it would give you some sort of preview. We've got another ref set filtering example. The members of the IPS reference set, which have changed since July 2021. So this will be useful for if you're doing some sort of new deployment of a new reference set, you want to know what reference set members have changed, what impact does that have on my system? Do I need to do anything? Yeah, so we're filtering by new components in the International Patient Summary reference set. Another example, here we've got a description type filter. So as well as filtering on where they are in the hierarchy, what attributes they have, we can also filter on which descriptions they have. And that uses all the terms. It uses the FSN, all the synonyms, any of the active descriptions. So we're saying I want all subtypes of disease that have a term matching heart at. This is the default matching algorithm is like multiple prefixes of terms. And they can be in any order. It will still work. It's kind of like the search you use in the browser. You could search for myoinfarct and it will find myocardial infarction. It's the same mechanism.
Does it always have to have at least 3 characters for it to be valid to search, like in the search box?
Yeah, the ECL specification doesn't say. We haven't constrained vendors, so it's down to the implementations. In our Snowstorm implementation, yeah, you need 3 characters. Otherwise, you'll get like a bad request error. Last example then. This is probably the most important. It's not a filter, it's actually a supplement. It's actually adding something to the results. This is a fairly recent development. It's the history supplement. So for data input, you should always use active concepts. But once you've got the data and you want to do reporting or analytics, you need to cover the active concepts and the concepts that have been inactivated in that area. So if we looked at all descendants and self of asthma, if we're doing reporting, especially over longitudinal data, we want to add the historic concepts. So this adds the concepts that used to be a type of asthma, and it leverages the historical associations which are published. So when we make a concept inactive, we say, oh, actually it's inactive because it's equivalent to this concept, or it was the same as this concept. It was possibly equivalent to these 2 concepts. So it will add in those inactive concepts. There's a question.
Pandora's box has been opened. So I'm kind of reacquainting myself with all this stuff. Well, my distant history or distant memory of the RF2 stuff was that the historical concepts were not their context wasn't maintained. And so you're alluding to the fact that that's not true, that in fact the historical concepts do, it is, somehow that this concept that was retired 5 years ago was in fact a descendant of asthma. which means either you're keeping the inferred representations of things throughout, or what are you doing? That's pretty
Yeah.
cool. And
So-
that's what, so that's one. And I have
Yeah.
another question that we're not gonna answer now.
Yeah.
But you gotta answer before we leave, and that is the impact of primitives on these queries.
So inactive concepts fall out of the hierarchy because all their relationships are made inactive, including their is a relationship. So they're no longer part of the hierarchy. They're kind of just off to the side. They still exist. They still have active descriptions. But they shouldn't be used for data input because they're inactive. So if we use the hierarchy to do a constraint as a descendants of asthma, we won't find any of the inactive concepts. And by default, that's okay. But we've given the mechanism that people can explicitly include those other concepts, and by saying plus history is the history supplement. And the way it works is it uses the historical association. So they're not relationships. There's like a reference set. So when the authors are in the authoring environment, wherever they are, and they say they're making a concept inactive, they've got to do two things, 2 bits of information. They've got to say, why are we making this inactive? Maybe it's erroneous, maybe it's ambiguous. We don't want ambiguous things in SNOMED. There's a range of reasons. So why is the first data point? The second data point is, what should we use instead? If we're trying to, do a migration to this new version of SNOMED, is there a concept that's the same as this equivalent, the same representation? So we're creating one or more associations. We could say, oh, this concept is actually the same as this one. It's a duplicate. Or we could say, we don't actually know, and it's not clear. It could be one of these, or it could be one of these. So there's different types of associations we can make to the active concepts, depending on what the situation is. Yeah.
There's a lot of concepts that have no mapped to. Are you saying those are going to drop out of this query? I'm not going to depend on this query if I can't be reliably pulling all the things that actually were in that hierarchy in the past.
Yeah.
And I'm not hearing that history is going to pull them out, because they will be someplace, every single one of them.
Yeah, sure.
So my question is, if I do a query and I do plus history, will every concept that's been retired reliably always be pulled based on that, or are there some concepts that will not?
We're relying on the content. If the content has the historical associations, they'll be pulled. You're right that if a concept doesn't have an associated,
But
yeah, it won't.
But it's really rare today that concepts are retired without an association. There are a few of them from very old times, but today it's very rare that the concept is retired without it. But also, well, it's depending how when you started coding with SNOMED. If you started 10 years ago, probably there will be a minority of concepts that are not linked.
We can't solve all the content issues in here. We're just trying to provide mechanisms for.
But for some years
it's a great
now,
question.
There has been a very strong policy about inactivating and assigning the right historical associations, the best ones available. Yeah.
And there's no way in the constraint language to search for inactivated relationships.
It's possible using a terminology server that has older versions of SNOMED to use the expression constraint language and pull the old stuff. I guess that's how you would do it. Yeah. But if you view it later as a snapshot with just the latest, then you can only pick up stuff that's got historical associations. And as Alejandro says, the authoring teams in the last few years know that this history supplement is here. They know it's very important. They, do best efforts to make those associations. It's not like a throwaway thing. We know that implementers need them for the queries to work. So it's really fundamental.
And this is not looking at the previous location in the hierarchy, because the concept was inactivated for a reason. Maybe that location was wrong. So we don't want to use that location. So they actually, what we look at is the decision of the authors to point to an active concept from the inactive one. And this is maintained. It's not like a chain. If something that is receiving connections from an inactive concept is inactivated, those connections are updated. So every inactive concept has a single link, or every now the recent ones, I mean, with an active concept.
All right, so good discussion in this session. I wanted to point to the ECL guide at snomed.org/ECL. And if you're new to ECL, you're welcome to have a read. But if you're like a kind of active learner, you want to jump to the examples section 6. And it starts off with the basics around simple constraints using the hierarchy, and it builds up to refinements, using the attributes. There's cardinality. You can jump into the sections you're interested in. But yeah, it's a great guide full of examples. And of course, you want to copy from the examples page, and you want to paste them into some browser that you have access to. In the international browser, the expression constraint area is here. We also have a query builder, which supports a subset of ECL. It's something that we'd like to do more with. You can add a focus concept and you can add refinements. You can't do minus, you can't do cardinality, you can't do role groups. It's got some basic stuff in there. The nice thing about the ECL builder is you can build up an ECL expression, using the form builder. But if you paste an ECL expression here and go to the form builder, it will pre-populate the forms. So it's kind of, it works both ways. So let's dig into creating some examples. Yeah. Sure.
What's the impact of primitives on when you do queries?
There's not really any impact.
There's no impact.
I mean, they impact the structure of the hierarchy, of course.
Right.
But when you run the queries are just using the structure of the hierarchy. There's no DL reasoning going on. You're not saying you're not asking for subtypes. Actually, you're kind of asking for descendants in the hierarchy because the hierarchy is already built.
Okay. Yeah, I guess you're right. You're not running a query. I mean, you're not doing DL. Okay.
And the primitives inherit attributes also. So even the primitives inherit attributes from parents. So if you create a leaf concept that is primitive with an ISA to a concept, after classification, we have all the attributes of your parent. Move further.
All right, let's talk a bit more about the concept model rules. So the concept model rules are documented in the editorial guide. This is the short link, snomed.org/EG. So where you can read about the different domains and the intention of them and the different attributes that are available and their ranges. There's also something called the MRCM, which is the machine readable concept model. So all those rules, the domains, the attribute types, and the attribute ranges are actually have now been coded into a set of reference sets, and that helps tooling. It helps the authoring tooling when you're creating concepts. You know that you're adhering to the editorial guide, but it's also useful for queries. And the ECL builders or UIs that help you ought to leverage the MRCM. So if you pick some concept that is in some domain, it should only give you the attributes that are applicable for that domain. Then you know that you're creating a query that's going to be valuable and that's going to work. So the MRCM browser is here, but we can go there easily if we go to the browser, go to the front page. It's just here, MRCM browser. The MRCM browser is kind of neat. It works in both directions. So if I select clinical finding, I get a filtered set of attributes. I can go the other way as well. I can start with some attribute, direct site, and it will highlight all the domains that it's applicable to. This one's just applicable to observable entity. We've also got the third column here, which is the range constraint. These can get a bit crazy. I'm going to look for a simpler one. I should probably go to findings and look for finding site, something like that. So for clinical findings, they can have a finding site as one of the most common attributes in SNOMED, and we've got the range here. So a finding site can have a value, which is any anatomical or required body structure.
So I'm noticing up at top, it's got a version, which is good.
Yeah.
Other versions? Is that
Yeah.
So it changes. So like, can you click on that? When was the last time it? Oh my God.
Not all of these have the MRCM, I don't think. I think it,
Oh,
maybe they do.
I was like, holy cow.
I'm not sure.
So, yeah,
they do.
when do we know when it changes and how it changes?
So the idea of the MRCM is it's published inside SNOMED.
Yeah, I hear that.
So you shouldn't go and, copy some version of the MRCM into your tooling. You should look in the SNOMED you've got loaded, because in there is the MRCM for the content that is in that version of SNOMED itself
Get it.
containing.
But maybe Alejandro is going to ask, but how do I know when it changes? This changes, because this is important.
I have a fun idea. You can use CCL for that. Like Kai said, this is stored in ref set. So the MRCM is stored as part of the terminology in reference sets. So it should be possible to create a reference set that looks at, an ECL that looks at the members with a filter that says updated after that date.
Let's do it. Let's do it.
Let's do it.
I'm doing it now. So we're saying, so there's a few reference sets, right, in the MRCM reference set thing. There's kind of a bunch. There's really 4 types, but then we've got these 3 ones that we actually published, the international ones. These were populated. They've got rows. But anyway, that's the different types of MRCM reference set we need to search over. But we can say, give me the members. Oh, I don't know how to use your keyboard, Alejandro. I'm used to a British keyboard.
Shift 7. I don't know how to use the UK one. He doesn't know how to use.
Oh no, I think I just don't. Oh yeah, that's okay. That's okay. We got it.
6. Oh,
Give me all the members of all the descendants of MRCM reference set.
try it like that first without the.
Yeah, we should see some. We're gonna hurt the terminology server. There's a lot. Oh, there's only 150. So in the results, we're only seeing what are the reference component of those rows. Each one of those rows has got loads more information, but you're interested in when something changes. So all we need to do is apply a filter here. We can say, I want a member filter. So I'm filtering reference set members, and I want to filter on the effective time. And
2 or 1.
And I want to say effective time is greater than some date. I don't know if the quoting will work, so we'll see and see what happens. What do you want to know? Since 2002, what's happened?
Yeah.
Oh.
Yeah.
January 2002, what's changed?
2002. Well, yeah. I think you need to.
I've got the wrong type of bracket. Do you know, I'm hoping this goes wrong. I'm hoping I've got something wrong because we're trying to do a tutorial, we're trying to do learning, right? So learning's a process. I've got something wrong. Perfect.
You need to color races.
So when you get this error down here, don't be like, oh no, tear your hair out. Try and just slow down, take a breath. Try and read it. It does say exactly what's wrong. It says character 40. Character 40. I mean, you're not really going to count how many characters you've got, but it's trying to tell you the position. Character 40, it says we've got a missing curly brace.
Yeah, because it's too open and too close.
Double curly brace for filters. Any more errors? No more errors. So we've got 24 rows that have changed since that date. So if I've loaded
do 2020, for example, to see.
Yeah. Well, no, we can do 2023. I'm not sure if any have changed. Or you can even do
with 2020, you will have the recent ones, which are not many. Yeah.
Okay.
How many?
91.
91 have changed.
Yeah. So you can find them essentially.
Oh,
you
probably.
can find when the rules change using a query.
Yeah.
So what is this telling you? That one of these things is changed. Is it usually that we're adding new constraints that were open in the past, or were concepts valid in the past and not valid anymore?
No,
Our authoring principle is that if we change the rules, then we change the content. We don't publish the international edition until all the content matches the rules that we're publishing at the same time.
Right, and those concepts are just, no change in anything, right? They improve.
Yeah.
Yeah.
They're different in a way.
Yeah.
The only way that you know that they're different is you do some kind of comparison cross version.
Yeah.
But your queries would presumably change from 2020 to 2023 in terms of what concepts you use, right? I mean, that's
Yeah.
the intent.
Yeah, exactly. The same query you can apply to a newer version and you get the new content.
Do you
You play with that in
Yeah.
the browser itself.
Yeah, exactly.
do you cover query maintenance in the last part of the tutorial?
No.
You don't. Okay. But yeah, it's an area. Definitely. All right. So we've covered the MRCM. Execution engines. So obviously, if you want to run ECL, you need some tool that can do it. This is not an exhaustive list. I'm not sure who built this slide. I'd like to see more up there. But some of the well-known ones are Snowstorm, which is an open source terminology server, and there's others, Onto server, Snowray. If you go to the implementation support portal, we've got a good list of reputable vendors who implement all this stuff. But essentially, I think the idea of this slide isn't to list them all. It's to say, whichever terminology server you use, you should be able to use the same expression constraint query, and you should get the same results if you're using the same version of SNOMED, the same substrate. So that's why we're standardizing all this. We've already done this, executed SNOMED queries in the browser. I'll just reiterate that the ECL builder is a good place to start with the basic stuff, hierarchy constraints, simple refinements. But as soon as you write something like this, here we've got a subquery because we've got these braces. I apologize, I didn't realize how small this was. Make it blow it up a bit. We've got these soft braces here, subquery, and we've obviously got a filter as well. The ECL builder can't do any of that. So if I start with this query and click ECL builder, I think it will just kind of not work.
Will not understand.
But yeah, hopefully we can
Show
improve
the
that in
help-
the future.
Show the help button.
Yeah, the help button's useful.
I always use these to build my ECLs. I copy from here.
It's the cheat sheet, right? Yeah. The short version. So lots of these will work in ECL builder. Let's take an example. Let's take this one. Clinical finding associated with any type of associated morphology. So I can copy some of these examples and I can paste them into the browser, and then we can click the builder and it populates the form. So it's kind of a nice way to describe what the thing is as well. I'm saying it's descendant of clinical finding. It's got an associated morphology which is equal to star. And we can change the operators. We say not equal to star, or we can say, give me the descendants itself of this, or give me the ancestors of clinical finding. There won't be any, there's only the root node, but for a different concept. If you select member of, then when you type in here, it should search reference set members, which is kind of useful. If you put something in here, which is in, some area in the hierarchy, you will only be able to select the attributes that are in that area in the hierarchy. So it gives you assistance. It's, yeah.
It doesn't do the number of things. It can't tell you what the properties are.
No, it doesn't. Yeah.
How other than opening up the files, how do you know what the?
You can extract properties, yeah. So if we look at the MRCM reference sets, for example, let's go and look at the domain reference set of the international. So if we look at this reference set and we want to know what's in there, we can say, give me the members of this. Not sure what I've pressed. I want this thing. Okay, give me obviously, if you just run that, you'll just get the concepts, which isn't that useful in this case. But we can say, I got to remember the syntax now. It goes at the front here. Yeah, I will try and make it up and see what happens. So if you do these square brackets, yeah, sorry. If you do these square brackets, then you can list in here which fields you want to see in the reference set. Or you can say star, and you should see them all. So here we've got all the fields of the reference set. And this reference set's like particularly crazy. It's got like templates in it, which I think we might be getting rid of because they're too complicated.
Can
But
you
it's got
make
some
up-
of the other useful
do
fields.
whatever you want in a reference, like make up new members, and that's not members, but I call those properties. What are you calling those things?
I'm not sure what the official term is actually. I think of them as fields. Yeah.
Fields. Yeah. Okay.
Okay. All right. So we've talked a little bit about the ECL builder. I think we've covered this. I think we're over to you, Alejandro. We've got a few more slides left on use cases. Yeah. I've had my fun.
Well, now we thought about showing how we use it around the. Rob, you got the microphone, I think it's fine.
Yeah.
Yes. How we use it. Sometimes use cases for ECLs are maintaining subsets, simple type subsets, helping to define the scope for mapping or translation, defining terminology bindings. This is really important. And of course, clinical decision support and data analytics. So let's see some examples of these things, and maybe we can look. One of them is for subset maintenance, for simple subset maintenance. This is very small, but let me see if I can close this here. Yeah, this is the tool that is used in SNOMED. This is small again, sorry. Let me see if I can. Yes, this is the RefSet utility to answer tools, yes. So if I select some of these, like clinical findings on the IPS, for example, this is a RefSet created in the RefSet and translation tool in SNOMED. This is a free tool that anyone can apply to use. When you create a RefSet, let's say I will add a local set, you can decide if the RefSet is add a new one, for example, like name ECL tutorial test RefSet. Let's make it, we have the option here to create it extensional or intentional. Yes, the extensional one is a RefSet that will grab one by one the members. I will say, this is a member, this is a member, this is a member, and I define a fixed list. And if intentional, and this is intentional with an S because it's an intentional logic definition. It's defined by itself. We actually use an ECL there to define the RefSet. So let's use an intentional, and then I have an example of a definition. So let's go to a browser and look for, let's say we want to create a RefSet for all types of diabetes mellitus. And we can delete this, and so diabetes mellitus and all the descendants. You can execute, let me do this. And you have 121 concepts. So I copy the ECL and I go back to a RefSet tool. I paste it here, and then I can add this new local set. I need the version, right? Oh, yes, this is a version that will run against. Good. So now we have a version. No, I'm missing something else. Description. Yeah. Yeah, exactly. I made a mistake in the. Oh. Okay, let's refresh because I don't see it. This is the IST testing project. Let's look. No. Tutorial. There, ECL tutorial RefSet test. Yes, and when you have it here, and below you see the members, 121. And this is how I created a RefSet based on that. If later I will go and change the edition to a later edition, let's say in 2 months, I go back to this tool and say, now we'll switch the RefSet to depend on December edition instead of October. And this will be automatically updated. and I will get the new count for December. Maybe a new kind of diabetes was added in December, or maybe some of these were inactivated and something like that. So in this way, I can maintain the ref set, and then I can click here and download a file with the ref set. Yes, yes.
You do a difference between two ref sets, or you only got the new content? No, you're getting all of the old content and the new content from this one, right?
No, you get all the descendant of diabetes that was.
But if,
Yeah.
but if, say you wanted to update, say there's a new release of SNOMED, there's some new content, but you just want to pick up the new concepts to add to your ref set.
But this is your ref set, so the system will do it for you. Let's say if I click here on the pencil. No, this is updating the definition. Let me see. Here. I click here on the pencil. And I say, instead of running on October, let's run on 2022 July. And I say, does this work okay? I'm going back in time instead of going forward, but it's the same in the sense of this will run again, and I will see if there's a difference. Yes, so far I have seen no difference. There's an action here, which is the delta that will show me the difference between what I have and what's there. Oh, okay, for the delta, I need to be released. Yeah, this tool, which is the ref set and translation tool, is much more than just creating a ref set. Allows you to create a ref set, publish, like create a published version that is fixed, and then start in the new release. And when you do that, you can get the report of the difference between the old one and the new one I have today.
Okay.
Yes, but still what you publish, it will not be the delta. You publish the whole ref set.
Right.
But when you put it in a SNOMED package, anyone can compute the delta.
Okay.
Because it will be a snapshot that you can compare with the previous one. Yes, but this is just, the goal here was to show how the ECL is what helps you maintain these complex ref sets in a dynamic way that is updated on each release. And
So
these are
if-
the screenshots. Yeah.
If you want to browse or see the member of your test, you have to create a concept test, right? In the SNOMED concept. So you need the author, name of the reference set first, and then you create your reference set, and then you export that to SNOMED browser, right?
Yeah, so
Okay.
yes, in order to publish this in an extension, it requires to have a
Right.
concept. Yes, but that is usually handled automatically by the different tools. In this case, this tool prepares the creation of the concept, and then when you go to a publication tool, it will make the creation effective. Like the simplex tool we were discussing before, you can use this content to automatically create the concept for you with the name you selected for this ref in the right part of the hierarchy.
Yeah, if you just wanted to run the ECL, obviously you could do that in the browser. And I guess with the ref set tool, you can create the reference set, and you don't. The ref set tool can create the concept for you, can't it?
Yeah, but it will just output the concept without an ID, or
Yeah.
you still need to go somewhere else to actually make it effective. It's like the output of the ref set tool is the concept and the members in different files. Yeah. And the other use case that we also is really common is to defining scopes. Yes, so the ref set and translation tool also works as a translation tool. So when you create a ref set like this, or the type of diabetes, you can go to the next button here. Yes, and I'll go to translation, and you can start the translation of one of those ref sets. Yeah, so you have defined a ref set, and then you translate the ref set. And maybe you never publish the ref set. It's just a ref set created for the purpose of scoping the translation. But also in the Snap to SNOMED, which is our mapping tool, when you create a new map, this tool is used. So if you have a local terminology, let me see if I did it right. Yeah. If you have a local terminology with local terms, or you have a vocabulary that you have a standard vocabulary in your country or something like that, you can load it into this tool, and this tool will try to find lexical matches for those terms in SNOMED. And there's a revision process that ensures that you have picked the right one. So when you create a map, what you do is you upload your source terminology, which is the terms that are used in your country to match with the SNOMED. But the interesting thing is you have a scope filter here, which is an ECL field. If you, for example, you have a local list of medications and you want to map with SNOMED, you say, this is my local list of medications and map only with medicinal products. So you don't get wrong matches. Or if you have a local list of procedures, you say map with SNOMED, but only in the procedure hierarchy, descendants of procedure. So in this case, you're using ECL to constrain the possibilities of the automatic matching that Snap to SNOMED does. Yes. This is an example of mapping a list of substances to the substance hierarchy, for example. Also, one important function of ECL is to define terminology bindings. And terminology bindings is to define what are the possible values that you can use in an information model. Yes, and HL7 Fire uses ECL to do that. We are looking here at the value set defining Fire for the allergy intolerance resource in Fire, that when you have the code of the allergy intolerance or the causative agent of the allergy, Fire explains what are the possible values for that field using ECL. So when you go to logical definition, it says includes codes from SNOMED using the SNOMED URI, where constraint equals all the descendants of pharmaceutical or biological product, all the descendants of substance, or all the propensity for adverse effect or reactions, and all the members of the international patient summary. This is like a filter. This is saying, yes, so for the IPS version and the international patient summary version of allergy, use either products, either substances, either allergy findings, but only the ones that are part of the IPS summary. Yes. So this is the ECL in this case is describing what goes in a field. And to show this kind of things, we have a demo tool that is our demo UI tool for this was a link there, like a fake electronic record that we can play around and see how it works. This is a page that looks like an electronic medical record, and we have reason for encounter and diagnosis and procedure fields for a fake patient. So if I write something in diagnosis like append here, yes, I get options that are all clinical findings. Yes, because this is the diagnosis field. If I want to see how this is done, I can click on the eye and I see the constraint here. This is using a constraint that is selecting only clinical findings. And if I go to the procedure field and I type the same search term, I get appendectomy, which is a procedure. And this is because here in this section, this field is constrained to procedure. So we have an information model and we are constraining the possible values of the information model using ECL. Yes. And if you want to explore this a bit more, we have another demonstration tool, which is the terminology binding tool that allows you to create the bindings yourself. Let's say I will add, this is like a form creator, very simple form creator. Let's say this is tutorial demo form, and this is a title. Yes, and you can add this. And we have our first field, which is as a title. And then we can say enter the dermatologic diagnosis. Oh, I'm typing all wrong. Well, I blocked the computer.
You're flying away.
Yeah. Yeah. Dermatologic diagnosis. And then you can say, I will use an autocomplete field, for example, for this form, and I will, with the SL builder, I will create something. So let's say skin finding, something like that. Skin finding, yes, this is skin finding. So I say descendant or self of skin finding. Yes, and if I do that and say enter derm at binding, I have a field like this, and I can type here and say, if I put something like red, like it will only be things that are red in the skin. Yes, red hair, red skin of face, red skin of nose, red skin of lid, because face goes red through red hair. The hair is part of the skin, apparently, for SNOMED. So this is how I'm constraining that. I'm creating a new UI based on that. So if then I want to put something like a field for severity, let's say, for the title is severity, and the type is, let's do options, and let's look for all the severities. Severity attributes, no, severity qualifier value. Which one is a qualifier value? Yeah, degrees of severity, exactly, that's a good one. And here, which one I will choose? I will choose descendant of, because if I choose descendant of self, will include degrees of severity, which is not actually something appropriate. So I use descendant of self, and I click here, okay, and then I add it, and this is adding first degree, third degree, and second degree. Yes, not what we were looking for, but it's interesting as well. Yeah, so we're creating a new UI, and we are using ECLs to find it, and then you can change the order or things like that. Yes, so this is how the ECL powers the user interfaces and the bindings to information models, and you can play around with this tool and explore. Yes, this is completely open. The new implementation course is using this tool for doing some assignments on when you're learning terminology bindings and things like that. It's an educational tool. And the other use case that we mentioned was patient analytics. And this is really interesting. When you have a large database coded with SNOMED CT, and you sit down with a data analyst and you want to start to dissect the database and create cohorts and identify groups of patients, you really need to use ECL. This is really, really useful. So if you say something like, give me all the patients with malignant tumors of breast, you need to start from SNOMED to do this query. You have all the patient data in your database, but the first query is not directly over the patient database, but actually is over SNOMED to get all the possible codes. So you say first, how do I get all the malignant tumors of breast? You look the concept and you say, give me this concept and all the descendants. And the patient data have all the different concepts there that have specific instances of different diseases. Some of them will be part of the ECL and some of them will be not. So what you need to do is to do a query over the patient data. This is like a pseudocode. It's something like SQL when it says, give me all the patients where the diagnosis has any value that is in the results of this ECL. Then you run the ECL and you get a list of values. Maybe you get 500 values or 100 values. And you use those to match the patients. At every patient that has one code that is part of your ECL results is actually a patient with some kind of malignant tumor of breast. Yes, so this is the 2 stages of analytics that you need to do. You need to query first with an ECL over a terminology server, get expansion, and then go to a clinical database and filter the clinical database according to the results. And for clinical decision support, this is interesting, but in the moment you need to create rules that will be applied to any patient, it's very useful to use ECL to create rules at a more general level. So that you can say that this guideline, for example, may be shown as an info button to all patients that have a diagnosis that is any kind of asthma or that is undergoing any kind of asthma management therapy or that has completed an asthma control questionnaire as a group of patients, yes. And then you specify that. And then when you're working with a particular patient and you write a diagnosis with a particular type of asthma, like chronic asthmatic bronchitis, this will match the ECL and you can display the alert or the informational data to the doctor. And also we have another example in the BAMNI project that we are demoing this week, in which we created these rules using ECL. This is, for example, the clinical decision support rules for contraindications between conditions and medications, yes, contraindications for medications. So the rule is in free text means something like all the conditions that are kinds of asthma are a contraindication for the prescription of any product that contains propranolol. Yes, and then in the instance of the record, you will have a very specific type of asthma that will be a descendant, and maybe you're prescribing a specific product of propranolol with some dose or dose form or strength. Yes, but if they match the rule, the alert will be present. So basically, this is what we have prepared for today. These are some pointers for more information, the specification that Kai showed before, the compositional grammar specification that also is a complement to that. The browser, playing the browser is really interesting and fun. And we have the MRCM browser to see which are the attributes, because when we start with ECL, people say, but what attributes should I use? How do I know that this is finding site and this is called procedure site? And there are two ways. One is to go to the MRCM browser and look at the source of the knowledge and understand that. But the other one is also to look at concepts. Yes, if you look at appendectomy, you see what attributes is appendectomy using, and you learn from that, and you say, okay, if I'm looking for a similar procedure, I use the same attribute that is used in this other similar concept. So there you have the two ways of trying to understand the concept model, either by examples or by looking at the specification.
Yeah, I just wanted to chip in. I think it's probably best to look at examples first. Think of 2 or 3 concepts that you're trying to match and see how they're modeled. Yeah.
Exactly.
Also, just to say that this is the first time we've mentioned compositional grammar. I probably should have mentioned it earlier, but that's the grammar used to create the SNOMED expressions.
Yeah, you showed expressions,
yeah.
but you didn't call it but like that.
That's where that comes from.
Yeah, but when Kai showed the concept expressions, those were compositional grammar. Yeah.
I have a question about translation. So we use RefSet tool and Snap to SNOMED tool for translation. Yeah. But I thought that there is no integration part. Yes, so when we export the output of RefSet tool, that we have to go through. It's not like automatically goes into when we create a extension. So you have to export it and then bringing those translation term as a synonym in the authoring tool. Is that still true?
You can explain, Kai. Yeah.
Yes, it is still true. The SNOMED international tooling around reference sets and maps and translation isn't very connected. There's some other vendors out there who provide like much more integrated solutions, and you translate something and it's in there straight away. But yeah,
but the managed service has a procedure to merge all together. Yeah.
Yeah, the managed service has a procedure to, where the technical team can put the things in for you. But yeah, let's take this offline. Let's wrap up the tutorial.
Yes, exactly.
Good question. Thank you.
Yeah, and that's all.